The headline sounds dramatic. California law to require Linux and Windows to implement age verification by January 1, 2027. At first glance, it feels like a seismic shift in how operating systems function. For decades, desktop operating systems like Windows and Linux have been neutral platforms. Tools that boot hardware, manage files, and run applications. Now imagine California mandates age verification. That's not a minor feature update. That would be a structural transformation of personal computing. To understand the scale of such a law, we need to zoom out. Digital age verification has shifted from a niche parental control feature to a frontline regulatory issue. Lawmakers worldwide are increasingly focused on protecting minors from harmful online content and manipulation. California, known for leading technology regulation, often sets precedents that ripple across the US and globally. Imagine California passing a regulation. By January 1, 2027, all major desktop operating systems must implement age verification. Not optional parental controls, not voluntary tools. Mandatory verification infrastructure at the system level. Immediately, several questions arise. What counts as age verification? ID checks? Biometric scans? Third-party providers? Would this apply only to new devices sold in California, or to software updates on existing systems? And how would open-source ecosystems, especially Linux distributions, comply with state-specific mandates? Let's begin with Windows. Microsoft's Windows operating system is proprietary software controlled by a single corporation. If California requires age verification, Microsoft could build compliance features into future Windows releases. It already has account-based login systems, family safety features, and parental dashboards. Extending that to age verification might mean requiring date of birth confirmation with some form of authentication. But there's a difference between self-reported age and legally verified age. If the regulation demands robust verification, the infrastructure becomes far more complex. Microsoft would need to integrate identity verification pipelines, possibly linking to third-party providers. That introduces privacy concerns, data retention obligations, and liability risk. Now let's consider Linux. Linux is not a single product. It's an ecosystem built around the Linux kernel, developed collaboratively and distributed under open-source licenses. There is no single company that controls Linux. Distributions like Ubuntu, Fedora, Debian, Arch, and OpenSUSE are maintained by different organizations or communities. If California mandates age verification at the OS level, who is responsible for compliance in the Linux ecosystem? Is it the distributor, the device manufacturer, the retailer, the open-source community? This is where the challenge becomes complicated. Unlike Windows, which can push updates centrally, Linux distributions vary in governance and infrastructure. Enforcement will likely target device manufacturers and vendors selling machines in California, rather than upstream open-source developers. Companies shipping Linux-powered laptops might need to implement compliance layers. Now let's examine the rationale behind such a law. The motivation would almost certainly be child safety and digital harm reduction. Policymakers are concerned about minors accessing adult content, violent material, and predatory online services. Traditionally, responsibility for filtering has fallen on websites and app platforms. But enforcement at the application layer is inconsistent. A state-level OS requirement would push responsibility down to the foundation of computing itself. In theory, operating systems could act as gatekeepers. They could enforce age restrictions before allowing certain applications to install or run. They could restrict access to content categories. They could require verified adult status before permitting web browsers to access flagged domains. However, that raises technical and philosophical concerns. Operating systems historically function as neutral infrastructure. Mandating age verification transforms them into policy enforcement tools. That shift would be controversial. Privacy advocates would immediately raise alarms. Centralized age verification systems risk creating databases linking identities to devices. Even if data is encrypted and minimized, the presence of verification mechanisms introduces attack surfaces. Data breaches could expose sensitive identity records. The more verification systems proliferate, the more valuable they become as targets. There's also the constitutional dimension. In the United States, free speech protections intersect with digital regulation. Courts have historically scrutinized laws that restrict access to online content. If an operating system blocks access, questions arise. Now let's think about implementation models. One model could involve decentralized verification tokens. Instead of storing identity documents, the system could verify age through third-party services that issue cryptographic proof of age. Zero-knowledge proof technology could theoretically confirm that a user is over 18 without revealing birth date or identity. But implementing such systems at the OS level would require coordination across hardware, software, and identity providers. Standards bodies might need to define protocols. The timeline to January 1, 2027 would be aggressive, but not impossible. Another possible model is hardware-backed age verification. Modern devices already include secure enclaves. Age credentials could be stored securely within hardware, reducing exposure to malware, but that increases development complexity and cost. Cost is a major factor. Compliance isn't free. Microsoft would allocate engineering resources. Linux distributors with corporate backing might do the same. Smaller community projects could struggle. Device manufacturers might pass costs to consumers. Would this create a fragmented market? Historically, large markets influence global design. The EU's GDPR reshaped global data practices. Because companies chose to implement EU-compliant frameworks universally rather than maintain separate systems. California, as the fifth largest economy in the world, has similar influence. If Windows implements age verification for California, it may deploy it nationwide. That could normalize age verification at the OS level across the United States. Now let's consider the user experience. Booting a new computer could involve identity verification steps. Creating a local account might require age confirmation. Certain features might remain locked until verification is complete. For families, this could simplify parental controls. For privacy-conscious adults, it could feel intrusive. There's also the question of enforcement. How would regulators verify compliance? Would there be audits of operating system releases, certification processes, penalties for non-compliance? Likely, enforcement would target vendors selling devices without compliant software. Developers would need new APIs to interact with OS-level age status. Applications might query the system. Is this user verified as over 18? The OS would return a yes-no response without exposing personal data. That could standardize age gating across apps. However, critics would argue that pushing verification down to the OS doesn't eliminate risks. Determined minors could use VPNs, secondary devices, or unregulated platforms. Technical restrictions often lead to circumvention efforts. Open-source communities might resist embedding mandatory verification code in core distributions. Forks could emerge that remove compliance layers. If those forks are distributed online from outside California, enforcement becomes murky. There is also a global perspective. If US states begin mandating OS-level age verification, other countries may follow. Some governments might expand verification beyond age into broader identity controls. That raises concerns about digital surveillance and authoritarian misuse. Supporters would argue that responsible digital infrastructure must evolve. Just as cars require seatbelts and pharmaceuticals require safety testing, digital systems might require protective mechanisms for minors. They would frame OS-level age verification as modernization rather than intrusion. Opponents will counter that operating systems are general-purpose tools. Embedding regulatory mandates at that layer sets dangerous precedents. They would emphasize privacy, autonomy, and the risk of mission creep. Technically, Windows is better positioned for rapid compliance due to centralized governance. Linux ecosystems are more distributed. Corporate-backed distributions could comply, but community-driven ones may not. Device vendors could implement wrappers around Linux kernels to meet requirements without altering upstream code. One practical compromise might involve mandatory age verification frameworks being available and enabled by default, rather than mandatory identity submission for every user. That would align with child safety goals, while minimizing friction. The January 1, 2027 deadline creates urgency. Major OS release cycles typically span multiple years. Planning would need to begin well before 2026. Developer documentation, hardware validation, legal review, and consumer education would all be necessary. Public reaction would likely be polarized. Parents concerned about online harms may welcome system-level safeguards. Civil liberties groups may file legal challenges. Tech companies may lobby for clarifications or amendments. Economically, compliance costs could disproportionately impact smaller OEMs. Larger corporations can absorb regulatory overhead more easily. That could indirectly consolidate market power. From a cybersecurity standpoint, age verification systems must be resilient. If attackers can spoof age credentials, the regulation loses effectiveness. Strong cryptographic design would be essential. Education and transparency would also matter. Users need to understand what data is collected, how it's stored, and how it's protected. Trust determines adoption. There's also the philosophical question of digital adulthood. Is age alone the correct metric for content access? Should maturity, context, or parental consent play roles? Laws often simplify complex human realities into binary thresholds. If implemented thoughtfully, OS-level age verification could integrate privacy-preserving identity proof standards. If implemented poorly, it could introduce friction, privacy erosion, and unintended consequences. Ultimately, the story is not about Linux versus Windows. It's about the evolution of digital governance. Operating systems were once neutral utilities. As society grapples with digital harms, pressure mounts to transform foundational technologies into policy instruments. Whether that transformation enhances safety without compromising freedom depends entirely on execution. By January 1, 2027, if such a law stands and survives legal scrutiny, the personal computer as we know it could subtly but significantly change. Boot screens may remain familiar. Desktops may look the same. But beneath the interface, identity verification logic could become part of the core architecture. And that would mark one of the most profound shifts in desktop computing since the rise of the internet itself.